this is a sum. This sum says differentiate with respect to x. Now this is what it is. Alright, so our job before differentiation is to make it simple for differentiation. So what do? As I taught you that we have got to find LCM. So I put 1 below this. So let's understand what happens. Now I first put in the bracket. So this becomes now the base is root 3x minus 5. These two are the values which we have got to consider. So 1 into root of 3x. So I write it 1 just for clarity. So 1 into, so in denominator we get 1 into root 3x minus 5. Alright. So 1 is already there. So I've got to multiply root 3x minus 5 with a root 3x minus 5. Alright. This root 3x minus 5 exists, and this root 3x minus 5 have come from the LCM. Alright. Minus. Now this already exists, so 1 into 1. So it would be minus 1, and close the bracket and put in the power. Got this? Now we know if we multiply root of a with root of a, it becomes root a square. That itself means a. That means root disappears. So what happens? So in next step what happens is we have 3x minus 5 minus 1 upon root 3x minus 5 raised to 5. Alright, you know this because root disappears because it's square. Alright, so this happens. So on simplification, what we end up with is 3x minus 6 upon root 3x minus 5, the whole raised to 5. See, the LCM thing helps over here. Alright, so this is what we got. Now if I say dy dx, now you have got to do d by dx of y, that is d by dx of 3x minus 6 upon root 3x minus 5 raised to 5. Then don't you feel d by dx u by v sort of thing, isn't it? This is u, this is v. So let's proceed. So let's get into it. So that would be used, but prior to that we also have got to use chain rule. I hope you know what is chain rule. Chain rule is now there are three packages, right? Chain rule is we have got to open outer packet to get into inner packet. We have got to open inner packet to get into innermost packet. So here the outermost packet is 5. Now this comes to the format of x raised to n, right? So when we differentiate this by dx, this becomes n x raised to n minus 1. So we are going to apply that to this first. Alright, so what we end up with is 5. This n is 5. So we have 5 over here, and then x, this is our x. So we write here 3x minus 6 upon root of 3x minus 5, close the bracket, and it is n minus 1, so 5 minus 1, so this becomes 4. And now we have got to also chain rule. We have opened the outer packet, now we are going inside. So when we go inside is d by dx of 3x minus 6 upon root of 3x minus 5. Now when you see this, here comes the u by v rule. Now for u by v rule we know it is v du by dx minus u dv by dx upon v square. This is the rule we know. Here v is root of 3x minus 5, and u is 3x minus 6. So let's proceed. So when we proceed, of course, it becomes a little bigger. So this is as it is, 3x minus 6, 3x minus 6 upon root of 3x minus 5 raised to 4. This we got as per this. Now this we have got to jot in. So it is v, that is this. So it is a root of 3x minus 5 and d by dx of u, that is 3x minus 6. Fine. Then comes minus, and then it comes u, that is 3x numerator, 3x minus 6, and d by dx of v, that is root of 3x minus 5. Alright, done. So numerator done. Divided by v square, that is root of 3x minus 5 the whole square. Alright, appears quite big, but it's very simple. So this now turns out to be, this part remains as it is, this also remains as it is. When we differentiate 3x minus 6, 6 being constant disappears, whereas 3x, 3 d by dx of x, dx cancels, so 3 remains out of this. Here also then comes minus, and here also this remains as it is, d by dx of root of 3x minus 5 is equivalent to that of root x. So the solution is 1 over 2 root 3x minus 5, and again chain rule, then we differentiate d by dx of 3x minus 5, that's what I've written over here. Now again here 5 disappears being constant, and instead of 3x what we end up with is 3. For simplicity's sake, what we do is we find 3 common over here, so we take 3 out and multiply it with 5. So what it forms is 15. This is equal to 15. 3x minus 6 upon the root of 3x minus 5. This remains as it is, and this now comes to root 3x minus 5 minus 3x upon 6. This comes to 3x minus 6 upon 2 root 3x minus 5. Alright, the whole divided by this thing, root of 3x minus 5 the whole square. Actually this also we could have changed it to just 3x minus 5 as root and square disappears. Alright, that's what we would do in next step. Now as the LCM part comes in, so let us make this as divided by 1. Alright, so numerator LCM play. Now this I would write it, I am just writing here, no, let me write it, I will write it here as 3x minus 6 upon root of 3x minus 5 remains as it is, raised to 4 remains as it is. Now what happens is LCM, that's what I taught in beginning of differentiation videos. So this goes there, so this becomes 2 into root 3x minus 5, that is this part which has gone there, multiplied by root 3x minus 5 is this one, minus here it is just 1 into 3x minus 6. Alright, and the whole is divided by 2 root 3x minus 5. Alright, so in next step what happens is it is 15 3x minus 6 upon 3x minus 5 under root raised to 4. Now here what happens is, now this I forgot to mention, this is divided by root 3x minus 5 the whole square. Alright, so now what happens in next step, this part remains as it is. Now this becomes, now since this is 2 root multiplied, so this becomes 3x minus 5, the root disappears. Alright, 2 into 3x minus 5 minus, now I open the bracket, so it becomes minus 3x plus 6, and this goes with the denominator. Here also what I have done is, it was square, so I converted it into 3x minus 5. Alright, and this is what is this, so we get here. So then what happens? Then finally what happens, of course this is not finally, lots to go. You have 3x minus 6 upon root of 3x minus 5 as it is, and here I open up the bracket, so it becomes 6x minus 10 minus 3x plus 6, alright, divided by, now see, this is root 3x minus 5 and this is 3x minus 5. So if I try to show it here separately, it would be what? 3x minus 5 raised to half into 3x minus 5 raised to 1. That is this and this. So as per law of indices, when base is common, we have got to add the power. So it becomes 3x minus 5 raised to half plus 1. That is equal to 3x minus 5 raised to 3 by 2. Alright. So what we have below here is 2 into 3x minus 5 raised to 3 by 2. Okay. Okay, this is what we got. Now what we do is we treat this. Now this also can be treated. Now 15. So I take this as 3x minus 5 minus 1. I didn't change the meaning of numerator, divided by root 3x minus 5. Alright. So this is what it is, and this remains as it is. 3x minus 4 upon 2, 3x minus 5, 3 by 2. Alright. Okay. So what do we do? Now we split it up. Now how do we split it up? 15 remains as it is, and this becomes 3x minus 5 divided by root 3x minus 5 minus 1 divided by root 3x minus 5. Alright, we just spread it up, this. So we just took this as this, we took it here, and this we took it there, minus staying in between. Alright, and this remains as it is. 3x minus 4 divided by 2 into 3x minus 5, 3 by 2. Okay. Now here again we know the theory of if 2 divided by root 2, that means what? That is root 2 into root 2 divided by root 2. So root 2 cancels, so root 2 remains as an answer. So same thing over here. This itself means if I want to write it like this, I can write it as this is root 3x minus 5 into root 3x minus 5 divided by root of 3x minus 5 minus 1 upon root 3x minus 5. Alright, and this remains as it is. 3x minus 4 upon 2 into 3x minus 5 raised to 3 by 2. Alright, this is raised to 3 by 2. Alright, 3 by 2. 3 by 2. Okay, so what happens? So obviously this and this cancels, so our final answer ultimately comes to root 3x minus 5 minus 1 upon root in this bracket. I forgot to mention, everywhere it was raised to 4, right? Everywhere it was raised to 4. Raised to 4, and this is 3x minus 4 upon 2 into 3x minus 5 raised to 3 by 2. Alright, okay. So this is what is our answer finally. Okay. Now this sum is very significant. Why? Because we got to learn many things. I always say once you are done with numerical, I don't ask you to by heart it, but I ask you to understand all the variation that we have applied for that particular numerical and keep it in mind. Alright, all the techniques that we have used to solve the numerical has to be kept in mind. So as you keep on doing more and more numericals, more and more techniques you would get, and you would be expert in solving numericals. Alright, so please follow it.